Assalamualaikum everyone. We are starting with differentiation and integration, and let's get started. So I think this is all good. I'm just checking the connection. Yeah, it's all good. So it's always a technical thing to get started with this. Thank you for all the comments. And let me just remove this thing from here. And wait a minute. Okay, I'm just thinking about, okay, that is minimizing this, and that's the Zoom thing. And the recording is on from here. Let me also share the screen of iPad. And I think we are all set and we are all ready to roll. So now we are starting with the midterm revision series for P3, and the focus is on differentiation and integration. Now what I've done is that I have highlighted some nice questions from the year 2019. So from the year 2019, I'm starting with this question that you see on the screen. So I've all listed like few questions over here. Let's see how many can we try out in about an hour's time or something like that. Now let's look at question number 1. Sorry, not question number 1, question number 4. So question number 4 says, show that this thing can be integrated between these two limits, and the answer should be given in the exact form. Now, first of all, let me take some sticky notes and let me apply over here. So now these sticky notes, they are basically about that what is the technique of integration that we need to apply. So the technique of integration over here is by parts. We know that by parts apply to a product of two functions, and then we use this formula integral of u dv, which is u v minus integral v du. And there is also this rule, that is the order for choosing u. What should be chosen as u? And that rule is LATE, L for log, A for algebra, T for trig, E for exponential. So now we have to apply this technique, and let me just reduce the brightness a bit, and all good. So now over here, we have x raised to power of negative 3 over 2 multiplying with ln x. So I'll write u equals to ln of x, a little bit of space, and dv equals to x raised to power of negative 3 over 2. Now we will differentiate u. So therefore du is 1 over x dx, and v is the integral of this, that is x raised to power of negative 3 over 2 plus 1 divided by the new power negative 3 over 2 plus 1, and this thing is done. I'll simplify it. Let me simplify it at this corner. X raised to power of negative 3 over 2 plus 1 over negative 3 over 2 plus 1. X raised to power of negative half divided by negative half, that is negative 2 square root, and this thing will go down, x raised to power of negative half, that is negative 2 over root x. So that is what we get over here. Now we will follow the arrows, and these arrows are like this. These two will be multiplied, these two will be multiplied, and there is a negative integral sign over here. So basically that is just my technique of writing it down, which I owe it to my teacher. I have learned it from him, and you people are learning from me. So this is uv, this is uv minus integral v du. So it's very methodical. That means you just see it and you follow it. So now this is, let's multiply it out. So this is negative 2 over root x, that is this thing. So this is negative 2 over root x ln x. These two things are multiplied. Put a bracket over here. This negative and this negative over here will cancel out and there is a positive sign. There is an integral and this is -2. It becomes positive. That is 2 over root x into 1 over x dx. I hope you are following this particular step. Now let me try out over here. This is 2. This is x raised to power of half. This is x raised to power of 1. Guess what? This is 2 over x raised to power of 3 over 2. This is 2x minus 3 over 2. So isn't this the same thing as this? Yes, it's exactly the same thing as this, except for the 2. So the derivative of this thing is again -2 over root x. Sorry, that's the integral. I'm using the wrong word. We are talking about the integral. The integral is this thing. So this 2 remains. Let's separate out this 2. That is a 2 over here. And this thing is -2 over root x. So this is -2 over root x. And we have this thing which was there before, -2 over root x ln x. All good, all clear? Now, one thing that we learn from integration is patience. So you cannot hurry up integration. You have to go step by step, especially when I'm teaching you this thing. So now look at the scenario. What is the first thing that's coming to your mind? I think it should be that we should take common. So what should we take in common? Let me get a highlighter ready. That is 2 root x negative sign, 2 root x and this negative sign. So this should be taken common out. So this is -2 over root x. And what are we left with? We are left with ln x plus 2. And now it's time to plug in the limits. So the limit applies to all. The lower limit is 1, the upper limit is 4. The lower limit is 1, the upper limit is 4. Now, if I want to, I can get rid of this negative sign and these two will switch their places. I think it's a good idea. Let's do that. So 2 over root x, this is ln x plus 2 and 4 goes down, 1 goes up. Now let's proceed. Let's first plug in the upper limit. So I'm plugging in 1. So that is 2 over root 1. This is ln of 1 plus 2. Close the bracket. Let me plug in the other value, which is 4. That is 2 over root 4. And this is ln 4 plus 2. And let me draw 2 brackets over here. The first one, the second one. This bracket I missed out and there is a negative sign over here. We know that ln of 1 is 0. This is 2 into 2, that's 4. This is 2 over root of 4, which is 2. So this is 1 and this is ln 4 plus 2. So this is negative ln 4 and 4 plus 2 is 6. So this is 2 minus ln 4. Now let me just look at it. Where is that small mistake that I have made? Now first thing is, this is x raised to power of -3 over 2 ln x. So u is ln x, derivative is 1 over x, that is perfect. X raised to power of -3 over 2, increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. This is -half, this is -half. Flip -half, that's -2. This is -half, this goes down, this is -2 over root x. Now, when we apply this, this minus and this overall minus makes it positive. The next thing is this indices over here. So x power half, x power 1, that is x power 3 over 2, x power -3 over 2. That's also good. So now the integral of this thing, this 2 remains, and this is after this 2. The integral of 1 over x raised to power of 3 over 2, that is -2 over root x. That's -2 over root x. That is all good. So now I took -2 over root x common, -2 over root x common. This is ln x plus 2. And then this minus sign is gotten rid of. This 4 goes down, 1 goes up. This is 2 over root x, ln x plus 2. And 4 is down, 1 is up. So 2 over root 1 ln of 1 plus 2, and this is 2 over root 4 ln 4 plus 2. So the answer has ln 4 and this 2. I think there's a plus minus mistake over here. So now this is plus 2. This is, I think, I forgot this minus thing. That is 4 minus ln 4 minus 2. And this is 2 minus ln 4. I think that was all a small mistake. And that thing is corrected. All good, all clear. It's always a good idea to double check your working. So now keep a timer with you and manage the time. If it's for 5 marks, that means when you are practicing at home, the number of marks should equal number of minutes. Marks should equal minutes. When you are giving an exam, the rule is marks, actually minutes, should be maximum equals to 1.5 times number of marks. So if you practice this thing, you will be able to reach this goal very easily. So that is one question that I tried out. Now another question, and this one is a little bit tricky, a little bit out of the box. So let's look at this question first. And okay, thank you. Okay, G. So now let's get started with this question. The variables x and y satisfy the relation sin y is equals to tan x, where y lies between minus pi by 2 and positive pi by 2. Show that dy by dx is equals to this thing. Now we have sine, we have tangent, we want everything in terms of cos. That is the first thing. So you realize this thing, that this is a scenario of differentiation of implicit functions. That is the first thing that you realize. Why? Because there is a y over here, there is a x over here. So the first thing that I should do is that differentiate both sides with respect to x. Differentiate both sides with respect to x. So we have sine y, we have tangent x. Now the rule is whenever you differentiate something in terms of x, it doesn't make a difference. When you differentiate in terms of y, you have to write dy by dx for compatibility. So derivative of sine y is cosine y multiplying with dy by dx. Differentiation of tangent x is sec square x. And let me do something on the sidelines. So let me draw a green box over here. No, not just a box. Okay, I think that would do the job. So now when I want to work something extra, I'll be doing it on the sidelines. The reason being so that the flow of the question is not disturbed. So now what is happening over here? I need to look at this relationship and somehow involve cosine over there. So now let's think of all the things that have cosine in it. We have the basic mother of all identities. And let me draw another box over here. We have the mother of all identities, that is sine square x plus cosine square x equals to 1. We have 1 plus tan square x is sec square x. And then we'll be using a double angle formula also. Okay, all good. Now the first thing that I'll do is that write sine y is equals to tangent of x. The first thing that comes to my mind is square both sides. Why? Because there is a square involved over here, there is a square involved over here, there is sec square over here. So that is what makes this question difficult, a little bit out of the box. Now, who would think about it in the middle of an exam that you have to do something? But such questions are those that differentiate between a person getting a distinction, a person getting an A star, a person getting an A. So there are some questions like that. Expect the unexpected. That's what P3 is all about. And nowadays P1 is also all about that. When I square both sides, I get sine square y is equals to tan square x. That is the first thing that's coming to my mind. Now I need cos. So let me apply this thing, that the sine square x plus cos square x is 1. Therefore, sine square y is 1 minus cos square y. And this is equals to tangent square x. That is the next step. Now we have 1 plus tan square x is 6 square x. And I need this thing over there. So therefore, what I can do is that, which is 6 square x, 1 plus tan square is 6 square. So let me write over here that cos square y. If I write this thing as what you call tan square as sec square x minus 1. That is one thing that's coming to my mind. Now, will it help? I need things in terms of cosine of 2x. I need something in terms of cosine x. So now look at this thing also. That is that there is an x over here, there is a 2x over here, the y is replaced. So if I want to replace y, let me just erase this thing. So 1 minus cos square y, this thing is tan square x. So now we have a cos y over here. We have a cos y over here. So therefore, what I can do is that I can write 1 minus tan square x is cos square y. That is the first thing that is coming to my mind. Now let's draw a box around it. That is the first thing. Now think about it. What is the next thing that needs to be done? Now keep in mind that we have to apply the idea that is that we have 1 minus tan square x is cos square y. Can I break up tan square x? What if I write 1 minus sine square x over cosine square x is cos square y? If I do this, I have cos square x minus sine square x over cos square x. This is cos square y. Now this makes sense. The reason being, this thing right over here, the orange thing which I'm highlighting, what exactly is this? Isn't this orange thing the same thing as a double angle formula? So cosine 2x is cos square x minus sine square x. So therefore, now I'm writing, let me remove this green barrier, and this is cosine of 2x over cosine square x. That is equals to cosine square y. Now, once I have achieved this thing, I can write cosine square y as the subject, cosine y is the subject. Therefore, square root of cosine 2x, square root of cos square x is equals to cos y. Got the idea? So now I have everything in terms of x. Now let me highlight this green thing. This thing over here, cos square y, that is equals to this thing, that is equals to this thing. This can be further simplified. Therefore, cosine y is equals to square root of cosine 2x over cosine x. And now this green thing is substituted, and this is square root of cosine 2x over cosine x. Dy by dx is 6 square x. And 6 square x can be written as 1 over cos square x. So I have written 6 square x is 1 over cos square x. All good, all clear? Now have a good look at it. I mean, this is the most difficult differentiation question related to trigonometry, related to implicit that I've seen. Now, who would think in the right sense of mind during an exam that you have to do this and then you have to do this. So this 5 marks, I mean, this is one of the most difficult one. There is also an algebra question, and that involved a graph, and that had chain rule, product rule, quotient rule. These 3 things were applied over there, and that was difficult from that perspective, from algebra perspective. This thing is difficult from the trigonometric perspective. So now this thing is done. The rest is basic simplification. So now if I cross multiply, I have to make dy by dx the subject. So dy by dx, that is equals to 1 over cos square x. This cosine x goes up, and this square root of cosine 2x goes down. So therefore this is 1 over cosine x, and this is square root of cosine 2x, and I think that is the answer. So that is dy by dx. All good, all clear? Of course, you have to do it one more time. So now the next sticky note that I'm applying over here is this thing, that lesson number 2, that is, or lesson number 1, from the examiner's perspective. From the examiner's perspective, from the teacher's perspective, what I want you to do is that once you have seen the video, whether you have seen it live, whether you have seen the recorded thing, the live will again become recorded. So now jot down the pointers. And what's the next thing that needs to be done? And try out the question once more. And try out these questions that I'll be doing once more. Unless and until you are ready to go this extreme length of trying things out, don't expect miracles to occur. This is P3. This is not P1. This is P3. So you have to try everything out in complete detail. Let's get started with another question. So I think these 2 were the ones that was from the February paper. Let me move to the next paper. Now, another implicit thing, and this thing is an easy one. There's no harm trying this. So now it says find the gradient of the curve at the point. So d by dx, this is x cube plus 3xy square minus y cube. That is d by dx of a constant 1. Over here, differentiate everything with respect to x. Whenever it's x, no issue. Whenever it's y, you write dy by dx. As simple as this. So therefore, x cube, the derivative is 3x squared. 3xy, this you have to work out, minus derivative of y cube. This is 3y squared. And then dy by dx, derivative of a constant is 0. Now over here, that is this thing, 3xy, you have to apply product rule. This is 3x into derivative of y square, which is 2y y prime, or dy by dx, plus y square, derivative of 3x is 3. Don't forget to write dy by dx also over here. So that is the basic knowledge that is applicable over here. Now, another thing that needs to be explained, another sticky note, that is this thing, that if in implicit or parametric, usually it happens in implicit, if they ask evaluate dy by dx, then no need of making or finding, no need of finding an expression for dy by dx. There's no need of that. So just plug in the value. What is the value? The value is 1, 3. That means x is 1, y is 3. So x is 1, that's 3 into 1 square, and this is 3 into 2 is 6, and x is 1 and y is 3, and then dy by dx, and y square. This thing y square is 3 square into 3. This 3 is this one. and this is minus 3y squared, 3 into 3 squared, dy by dx equals to 0. So now over here, 3 into 1 square, that is 3. 6 into 3, that's 18, dy by dx. This is 3 square is 9 into 3, 27. And this is minus 27 dy by dx is equals to 0. So we have dy by dx, we have dy by dx, 18 minus 27, negative y, dy by dx. 27 plus 3 is 30, taken to the other side, that is negative 30. So therefore dy by dx, that is equals to negative 30 over 9. Negative cancel out. So let me just erase this negative sign. 10 over 3, that is the answer, and that is the gradient of the tangent. They simply asked us dy by dx. We should know that dy by dx is gradient of tangent, negative reciprocal, that is the gradient of the normal. So now this was a basic question, that's done. Another one. Now trigonometry with integration with a flavor and spice of what? That is addition formula, double angle formula, things like that. So basically, when we talk about calculus, that is the advanced name for what you study with differentiation, integration, differential equations in university. So when we talk about differentiation, integration, and differential equations, that is like 3 topics out of 9. So technically it's 1/3. That means 25, 26, 24 marks out of a complete paper that is designated for these 3 topics. I have already taken a class of differential equations. So that would be in one of the videos. Other videos, you can check it on the channel. So currently I'm focusing on differentiation, integration, and all the chapters that you have studied before: logarithm, exponential, partial fractions, maybe something to do with polynomials, trigonometry, addition formula, compound angle formula, double angle formula, basic trigonometry of P1. Everything is there to serve differentiation and integration. So expect the unexpected. Everything will come, and it does come. So now it says, by first expanding this thing, show that. And that this is a very, very famous identity that has been coming from all the ages. So first thing is sine bracket 2x plus x. The first thing is addition formula. Sine A cosine B cosine A sine B. So basically, I am treating this thing as A. I am treating this thing as B. So sine A cosine B cosine A sine B, that is what I have treated this. And it's getting a little bit darker. So let me just highlight this like this. Okay. The next thing, I want everything in terms of sine. So first of all, use the double angle formula. Sine 2x, that is 2 sine x cosine x. And cosine 2x, I'm using 1 minus 2 sine square x. Now, I remember these formulas. Those people who are practicing it very well, they also remember it. For those people who are not so thorough with that, take out your formula booklet, MF19, flip the page and have a look at it. So now over here, this is cosine x plus sine, and over here, this is sine x. So the two formulas that I have used over here, let me highlight them. The two formulas are over here. The first thing, that is sine 2a. I'm deliberately writing in terms of a because x is already there. Sine 2a, that is 2 sine a cosine a. And cosine 2a, we use one of the formula in that implicit thing. That is cos square x, cos square a minus sine square a. That is 2 cosine square a minus 1. That is 1 minus 2 sine square a. That is cosine 2a. Now over here, if I multiply it out, this is cosine x. Let me highlight this. This is cosine x. It will multiply with this. Over here, this is sine x. It will multiply with this as well as this. So keep that thing in mind. Now, people, I appreciate that you asked me questions about this thing, how to manage self-doubts. For right now, what I can say is that just practice a bit. Don't over practice. but whatever you practice, have a clear concept of it. Make sure your notes are all good. They're as good as what you see on the screen. Make it colorful, make it short, make it concise, develop a formula sheet, everything jotted down on a piece of paper so that you know exactly this is what could be coming in the exam. Of course, unexpected things would occur. I do realize that. But self-doubt has a lot to do with practice and clarity of concept. So at this moment, that's all I can say over here. I hope it helps. So now when I open this up, what happens is that we multiply it out and this becomes 2 sine square x cosine 2 sine x cosine square x. So 2 sine x cosine square x. And over here, this is sine x and this is negative 2 sine cube x. Now, what is left? The last thing, the last piece of the puzzle, that is cosine x. Now use cosine square x is 1 minus sine square x. So this is 1 minus sine square x. And on the outside, this is 2 sine x. This is plus sine x. This is minus 2 sine cube x. So sine x into 1. Now let me write in black color. 2 sine x minus 2 sine cube x plus sine x minus 2 sine cube x. So now I have sine cube over here. I have sine cube over here. That is negative 4 sine cube x. I have 2 sine x over here. I have 2, not this one, the other one. And this sine x over here. So let me just deal with the nib. That is 3 sine x. And I think that is the answer, 3 sine x minus 4 sine cube x. That is basically sine 3x. So by first expanding this thing, this is sine 3x. So that's how this thing is done. Now let's look at the thing that's right in front of you on the screen. And what you can see is that what are the different identities that I have used. Now the first thing, let me put some highlights over here. The first thing that I used, that was addition formula. So the first thing was addition formula. The second thing that I used, that's right over here, that has been used twice. That is this double angle formula for sine 2a for cosine 2a. That is the second thing. The third thing that I used, that is right over here, marker is black, and this thing over here, that's the third thing that's used. What exactly is that? That is using the mother of all identities, that is sine square plus cos square equals to 1. That is over here. We substituted cosine square as 1 minus sine square x. So now 4 marks for that. So basically, what is trigonometry? Trigonometry is applying the right formula, the right identity at the right time with a lot of algebra. So it's not just about the identities, it's about algebra also. As we have seen in that previous question, a lot of algebra was there. Now, what is the next part? The next part is this thing, hence showing all the working, all the necessary working, find the exact value, focus on this. So now let me take out a sticky note and let me focus over here. That is whenever they are using the word exact. From the perspective of P3, 4 things comes to mind. Or maybe you can say 5. The first thing that comes to mind is fractions. That is exact. The second thing that comes to mind is in terms of pi. The third thing is that in terms of surds, radical. The fourth thing, that is in terms of E, and the last thing, that is in terms of ln. So these first 3 things, this is also in P1, this is P1, this is P1. And these two are specific of P3 in terms of E, in terms of ln, that is P3, but knowledge of P1 is also assumed. So now when they are asking the answer for this one, basically they are saying that hence use something from before. So we know that sine 3x is over here, it says sine 3x is 3 sine x minus 4 sine cube x. So let me write over here. Sine 3x is 3 sine x minus 4 sine cube x. In other words, 4 sine cube x, I'm taking it to the other side, that is 3 sine x minus sine 3x. And only sine cube x, that is 1/4 of 3 sine x minus sine 3x. All good, all clear? No rocket science over here, except the fact that O-level maths knowledge is necessary. So now, let's move on. Integrating sine cube x is integrating 1/4 bracket 3 sine x minus sine 3x. And now the limits are 0 and pi by 3. Another sticky note, because it might be handy, and just making it a bit bigger, that all these trig ratios are needed. Sine of pi by 6 is half, that's the same thing as cosine of pi by 3. Sine of pi by 3 is root 3 over 2, that is the same thing as cosine of pi by 6. Sine of pi by 4 is root 2 over 2, the rationalized form. You can also use 1 over root 2, that is cosine of pi by 4. Tangent of pi by 6 is root 3 over 3. Tangent of pi by 3 is root 3. I can also write this thing as 1 over root 3. And tangent of pi by 4 equals to 1 over 1, which is 1. So now this it should be on your fingertips. Those people who think they have bought a calculator and now they would keep on plugging in, don't complain at the end that you run lack of time. So this is something that you keep on using. So I mean, just get hold of them. This is not in the formula booklet. You have to remember it with clarity. So remember these, that's how it works. And I have made it easier. Sine of 30 is the same thing as cos of 60. Sine of 60 is the same thing as cos of 30. Sine of 45 is the same thing as cos of 45. Sine of 90 minus theta is cosine theta. Cosine of 90 minus theta is sine theta. Tangent of 90 minus theta is 1 over tan theta. Okay? So a little bit of math wrap, and let's move ahead. Let's get this integrated. So this is 3. Integral of sine is negative cosine x minus. Integral of sine is again cosine, and there is minus 1/3 cosine 3x. And let me just write this thing perfectly, something like this. So now this minus and this minus, that would make it positive. And don't forget the 1/4 on the outside, don't forget 0, don't forget pi by 3. Let me double check. 0, pi by 3, and this thing. So now this becomes negative 3 cosine x plus 1/3 cosine 3x. And this is 1/4, and this is 0, and this is pi by 3. We know this thing, that integral of sine ax plus b dx, that is negative 1 over a cosine ax plus b plus a constant of integration, which is not applicable because this is with limits. Now let me focus on the upper limit, that is pi by 3. So this is negative 3 cosine pi by 3. This is 1/3 cosine 3 times pi by 3 is pi. All good? Let me put a big bracket on the outside. Let me write a 1/4. Let me put a big bracket over here. Let me use another color, which is 0. And let me use this blue color. So now another bracket, which is negative 3 cosine of 0. And this is 1/3 cosine of 0. You can draw a bracket if you want to. I think that looks good. And let me just close this like this. And let me put a negative sign over here. Again, patience is a virtue, use it. We should also know that cosine of 0 is 1. We should also know sine of 0 is 0. But right now we just need cosine of 0. So cosine of 0 is 1. Cosine of 0 is 1. Cosine of pi is negative 1 because I can get all these things from the graph. This is pi, this is 0, and this is 2 pi. So cosine of pi is negative 1. And over here, cosine of pi by 3 is half. So now once you have substituted everything, that 1/4 is waiting on the outside, involve it at the very end. First the red bracket, then the blue bracket, then this again big curly bracket with a minus sign in the middle. So this is negative 3 into half, that is negative 3 over 2. 1/3 into negative 1, that is minus 1/3. And minus sign, this minus 3 into 1, and this is 1/3 into 1. Okay, so far so good. So now I need the answer in the exact form, and this is which question? This is this thing, the variant 31, question number 6. Okay, so I think I've written down the answer somewhere over here, and yes, let's just work it out. 3 over 2 minus 1 over 3. So 3 over 2 plus 1 over 3, 2 and 3 is 6. So therefore 6 divided by 2 is 3, 3 into 3 is 9, 6 divided by 3 is 2, 2 into 1 is 2, 9 plus 2 is 11, that is 11 over 6. So this is negative 11 over 6. This is the red thing. Minus a minus 3 plus 1/3. So that is 3 minus 1/3. That is 9 over 3 minus 1 over 3, which is 8 over 3. But it is negative minus 8 over 3. And don't forget the 1/4 on the outside. And this 1/4 is there. This is minus 11 over 6 plus 8 over 3. So this is minus 11 over 6 plus 8 over 3. This minus and this minus made it positive. So 11 over 6 and 8 over 3. 8 over 3 minus 11 over 6. Let's multiply by 2. Multiply by 2. That is 16 over 6 minus 11 over 6, which comes out to be 5 over 6. So this is 1/4 into 5 over 6. And yes, I got the correct answer. That is 5 over 24. So now this thing, that anxiety is always there. Someone asked this thing that about the self-doubt. So when you do these questions, you have to be very, very tricky. Yes, you are using all the knowledge that's given over here. But until and unless you do every step correctly, till the very last step, that anxiety is there. Even when I'm doing it, that particular anxiety has to be there. Now, someone asked this question, can we do it using isolated trig ratios knowledge? I technically did not understand. If you're talking about these trig ratios, naturally you have to use it. Otherwise, if you want to elaborate on the question, I can listen it over there. See it over there, not listen. So now this thing is done, and let's move on to this one. So now another question. Now this involves ln. This is May-June 2019, variant 32. So now over here, it says find the exact coordinates. Again, the wording is there. That is the exact coordinates of the point, that is one single point, on the curve, that is the equation at which the gradient of the tangent is equal to 1/4. We know that gradient of tangent is dy by dx. So we have to make it equal to 1/4. That is one thing. The next thing, y is equals to x over 1 plus ln x. Now it's application of quotient rule. So let me write quotient rule over here. That is a derivative of u over v. that is equals to v square v u prime minus u v prime. Keep that in mind. So u is x, u prime is 1, v is 1 plus ln x, v prime is 1 over x. Derivative of 1 is 0, derivative of ln x is 1 over x. Now, this person who's asking this question, even if you break down sine and sine square x in the previous question, how will you solve it further? You cannot solve it any further unless and until you use that identity, and plus they have used the word hence. So you have to use the identity. There is no other way of solving it. So let's move on. Now I'm starting with this, that is v and u. So I'm using this thing. Let me just draw this line like this. This is vu prime. So just to give yourself an idea, dy by dx is equals to 1 into 1 plus ln x minus x into 1 over x. And this whole thing is divided by what? That is this thing which is 1 plus ln x the whole thing square. So now this is 1 plus ln x the whole thing square. All good, all clear? Now, once you have this thing, let's proceed. This is 1 plus ln x minus 1, and this thing is divided by 1 plus ln x the whole thing square. So this is ln x over 1 plus ln x the whole thing square, but it's not over yet. That is the thing that we got the dy by dx. Now we have to equate it to what? We have to equate it to 1/4. So now dy by dx equals to 1/4. That is ln x over 1 plus ln x. The whole thing square is 1/4. And now we are getting a quadratic equation. Strange, very strange. For ln x, this is 1 plus ln x the whole thing square. And this one is just 1. So this is 1 plus 2 ln x plus ln x the whole thing square, and this is 4 ln x. So 0 equals to ln x the whole thing square plus 2 ln x minus 4 ln x. So how much is that? That is negative 2. So negative 2 ln x plus 1 equals to 0. Now first go ahead and double check my working. Till that time, let me just look at the comments. Someone asked this question: what's the best way to finish the last 5 years to get a good grip for the exam? The thing is that, I don't want to give any clickbait type of answer that do this and this will happen and this will happen. Nothing like that. The usual practice, understanding, it never goes out of style. So the regular practice, the regular methodology, practicing, understanding, thinking about it, developing a passion for it. That's the old school way of doing it, and that still rules. So that's the way of doing it. So now we have this equation, and now they are asking us, this is for 7 marks. Okay, one more thing. I forgot to focus on the mark. That is 7 mark. That means it has got a lot of stuff. 7 marks out of 75. You don't expect it to be easy. Conceptually, yes, it's easy, but what you are getting over here, do you know what you're getting over here? You are getting a disguised quadratic equation in terms of ln. So now make a substitution. Let u equals to ln x. Therefore, u square is ln x the whole thing square. And I need some more space. So I think if such a scenario happens in the exam, what you do is that first of all, no, not this thing, I need this. First of all, I have this liberty over here. Right now I'm using it. But in reality, when you do this thing in the exam, start from the very left hand side, like this. So that if you need something, then you draw a line in the middle like this, and then you can work it out. So now let me work it out over here. So this is u square minus 2u plus 1. So this is u square minus 2u plus 1 equals to 0. Will it factorize? I think so. This is u squared minus u plus 1 equals to 0. And this is u minus 1, and make it bigger. This is minus 1, u minus 1 equals to 0. It's a very beautiful number. U minus 1 equals to 0. U minus 1 whole square equals to 0. Therefore, u comes out to be 1. But what is u? U is ln x. But u is ln of x. So ln of x equals to 1. Therefore, x is e raised to power of 1, which is e. And we need the exact coordinates in terms of e. So therefore, what is y? Y is x over 1 plus ln x. X over 1 plus ln x. That is e over 1 plus ln e. This is e over 1 plus 1. This comes out to be e over 2 or half e. Therefore, the exact, focus on the word exact. The exact coordinate is e comma half e, and that is the answer that we get over here. Now just have a good look. That's for 7 marks. A lot of working for 7 marks, and I think in one of the question I wrote about the exact thing. So now this is exact in terms of e. Okay. Now let's move ahead. Is there any other question in this one? This I solved earlier. Okay, partial fractions and integration. Okay, let's get started with this. Now, what is the checklist for partial fraction? For partial fraction, the checklist is 2. The first one, check whether it's a proper versus improper algebraic fraction. What is a proper algebraic fraction? Focus on the highest power in the numerator. Focus on the highest power in the denominator. The highest power in the numerator is 1. It's linear. The highest power in the denominator after multiplication is cubic. Why? Because this is quadratic, this is x, that makes it cubic. So yes, this is a proper algebraic fraction. So the first thing is done. The second thing is decide on the case. Which case is that? Is it the linear case? Is it the quadratic case? Is it the linear with a square on the outside, which is called linear repeated case? Which one is this? It's a linear on the outside. Of course, the linear will be there, but what is the dominant thing? The dominant thing is linear with a square. So therefore, let's get started with this. 10x plus 9 divided by, and this is 2x plus 1. So let me write it properly. This is 2x plus 1 and this is 2x plus 3 whole square. Let me use the eraser over here, the precision one. And this equals to a constant over the linear factor, which is 2x plus 1. Another constant over the linear repeated, but without the square, 2x plus 3. Another constant over 2x plus 3 whole square. That is the first thing that needs to be done. So I hope the first concept is clear. Now, I want you to learn from me, since you are applying your time, investing your time, whether you are watching it live, whether you are watching it recorded, is that what are the things that I focus on? The pointers, the sticky notes that I'm putting over there, what are the things that I'm focusing? So when you go back, pause the video, take your time, jot it down, and then proceed. So over here, the first thing that needs to be done is this thing, that is, I need to take the LCM. The LCM should be the same. This is 2x plus 1 and this is 2x plus 3 whole square. Now this A multiplies with 2x plus 3 whole square. This C multiplies with 2x plus 1. This B over here multiplies with 2x plus 1 as well as 2x plus 3. That is the thing that needs to be done. Now the sleeve of the Apple Pencil, it keeps coming down. So let me adjust it. All good, all clear. Now you would say that what is happening? is that this thing equals to this thing because the two fractions are identical. So let me write over here the first thing, 10x plus 9, let me use a bracket, that is identical to a times 2x plus 3 whole square, b times 2x plus 1, 2x plus 3, and this is c times 2x plus 1. Now what we will do is that, first thing is there, let x equals to negative 3 over 2. Now how do I get this value? A lot of people, they ask this question. If I equate this bracket equals to 0, 2x plus 3 equals to 0, x is negative 3 over 2. So this will disappear, this will disappear. So therefore 10 into negative 3 over 2 plus 9, this equals to identical to c times 2 negative 3 over 2 plus 1. So now let me do the working. That is over here, the 2 1s are, 2 5s are, negative 15 plus 9, which is negative 6. 2 and 2 cancel, negative 3 plus 1 is negative 2. That is equals to negative 2c. Therefore, c comes out to be positive 3. That is the first thing that is achieved. Now, let me rewrite this thing. I can plug in the value. I can skip the value. I mean, it's my choice. I think let's plug it in. 10x plus 9 is equal to identical to a times 2x plus 3 whole square, b times 2x plus 1, 2x plus 3, c which is 3, and this is 2x plus 1. So basically I have written it again and I have inserted the value of c. So that is c. Now let me choose, let x is equals to negative half. How did I get this thing? 2x plus 1. This is 2x plus 1 equals to 0. X is negative half. So now x is negative half. So therefore this thing will disappear. This thing will disappear. I'll be left with this. So therefore this is 10 into negative half plus 9, bracket closed. That is equal to or identical to, doesn't make a difference. This is 2 times negative half plus 3 whole square. Okay, over here, this 2 1s are, 2 5s are, negative 5 plus 9, which is 4. And 2 1s are, 2 1s are, this is negative 1 plus 3 is 2, 2 square is 4. So this is equals to 4a, therefore a comes out to be 1. So now I have also found the value of a. Let me rewrite it again. 10x plus 9 is equal to a times, which is 1 times 2x plus 3 whole square. B, that is what we are looking for. That's unknown. 2x plus 1, 2x plus 3. And this is c, which is 3 times 2x plus 1. Let me highlight it once more. So now we have substituted the value of a, not this thing. We have substituted the value of a. We have substituted the value of c. So the only unknown thing that remains now, that is this thing, which is b. And that is what we are looking for. So now choose any other value. So let x equals to 0. Let's choose a simple value. 9 equals to 1 times 3 square, b times 1 times 3, and c is 3 times 1. So this is 9, this is 9, this is 3b, this is 3, the 9 and the 9 cancels out, 0 is equals to 3b plus 3, therefore b comes out to be negative 1. So we found the three things. We found a to be 1, so let me write in green color. A comes out to be 1. We found b, b comes out to be negative 1. B comes out to be negative 1. And c came out to be 3. So that's how the three unknown constants are found. And how many marks are you getting? You're getting 5 marks out of that. 1 minus 1 and 3. Let me write it on the next page. So let me write 1 and then over something, minus 1 over something, and then this is 3 over something. So now the partial fractions, that is this thing, which is 2x plus 1, 2x plus 3. So this is 2x plus 1 bracket. This is 2x plus 3 bracket. This is 2x plus 3 bracket whole square. Now, when we are ending this answer over here, the first part, so make sure that you write the final answer in the proper format. Now, no matter how much effort you have tried, if you are not following the directives of the examiner, you are bound to lose marks. So follow the directives. So this is 1 over 2x plus 1 or 1 plus 2x, no 2x plus 1. This is minus 1 over 2x plus 3. This is plus 3 over 2x plus 3 whole square. This is the partial fraction. So you have to write it as fractions. Do not leave the answer as like A is this and B is this and C is this. Leave the answer in the proper way. Now they are asking us that what, hence show that the integral of this function fx, this thing is fx. The integral of this function fx, which is right over here, is this much, and the limits are there. So now let's get started on a roller coaster ride, and it's about integration 0 to 1, the bracket over here, dx, between the limits. Now let me draw a knowledge box over here. Not this one, I think this one is good. That is, if we are integrating ax plus b raised to power of n dx, that is ax plus b raised to power of n plus 1 divided by n plus 1 divided by coefficient of x plus c. It has two limitations. It applies to linear expression only, and the second limitation is it's valid for all powers except negative 1. What if the power is negative 1? So 1 over ax plus b dx, that is 1 over a ln ax plus b plus a constant of integration c. So now over here, what is applicable? Over here, this one and this one. These two will fall into this category. And this thing over here, that will fall into this category. Have a good look at it. And let me just reduce the size because I need a lot of space. When we are doing all this thing, the integration and differential equations and differentiation or P3 in general, so you need a lot of space. I've just reduced it and pushed it all the way up till here. It's for 5 marks. So now let's get started. Focus on the coefficient of x, this is 2. Focus on the coefficient of x, this is 2. Focus on the coefficient of x, this is 2. Now I need to write one more step before we proceed. And that is that 0 to 1, 1 over 2x plus 1. This is 1 over 2x plus 3. And not this whole thing. I think there's no need of drawing this whole bracket. So let me just remove this bracket. And this is plus 3 2x plus 3 raised to power of negative 2. And then let me write dx. Now it's ready to be integrated. So this is 1 over 2 ln 2x plus 1. Minus 1 over 2 ln 2x plus 3. 3 as it is, 2x plus 3 raised to power of negative 2 plus 1 divided by negative 2 plus 1, divide by the coefficient of x, which is 2, and let's put a bracket over here. And the limits are 0 and 1. Simplify it further. So this is half, this is ln 2x plus 1 minus ln 2x plus 3, bracket closed. Over here, what do we have? Negative 2 plus 1 is negative 3. Negative 2 plus 1 is negative 1. And then there is a 2 over here, negative 2. So this is negative 3 over 2. And this is 1 over 2x plus 3. All good, all clear. So a big curly bracket over here, a big curly bracket over here. Minus 2 plus 1, let me use a highlighter, a small highlighter. Minus 2 plus 1 is negative 1, so that's why it goes down. And this over here, this thing, that is this 2, this 3, and this minus 1, that is giving me this. Over here, what do we have? We have taken this half common out. The minus sign remains, and then there is ln, then there is ln. All good, all clear? Now the limits are 0 and 1. So this is 0, this is 1. Let me use a red marker for the upper limit. So this is half. This is ln. 2 plus 1 is 3. This is 2 plus 3 is 5. All good. This is minus 3 over 2. 2 plus 3 is 5. So minus 3 over 2 into 1/5. All good. Curly bracket. Then black marker. Then another curly bracket because of this thing. 0. So this is half ln 1 minus ln 3. Put a bracket over there. And then negative 3 over 2. If I plug in over here, that is minus 3 over 2, and this is 1/3. And I think I have the answer over there, so I can always double check even if I make a mistake. So now let's get started with this. This is ln 3, ln 5. This is half ln 3 over 5 according to rule of log. I'll just come to that in a short while. This is minus 3 over 10. So let me close the bracket. This is 3 over 10. Then this curly bracket. Now it's time for the blue bracket. Ln of 1 is 0. So this minus and this minus, that makes it plus. So this is half. And this is ln 3. Plus half ln 3. No, actually, let me write with the negative sign. Hold for a second. So this is minus and this is ln 3. The black sign is still there. The negative sign is still there. And what do we have? This is negative 3 over 2 into 1/3. That is negative half. That is negative half. That's over here. And the bracket is closed. So now the half, I think I missed out the half. So let me just write down the half over here. So blue marker, and this is negative half. Now I want you also to first look at the answer closely. I'll inspect it in a short while. I want you to first have a good look at it. Is everything in place? Is the integration done correctly? Have I taken care of the positive negative sign? If I have taken some common, is it all good, all clear? Now it's my choice that I took this half common out. Even if I don't, it doesn't make a difference. You can take it common after you insert the values. So I think it's all good. Let me just double check from here. If I plug in 1, this is 2 plus 1, which is 3. This is 2 plus 3, which is 5. This half remains. That's over here. 3 over 2 and 2 plus 3 is 5. 3 over 2 into 1/5. That's all good. If I plug in 0, this thing is gone. So this 3 and 3 over 2, that cancels. I'm left with half. Ln of 1 is 0. Ln of 3 is there. This minus remains. Minus ln 3 over 2, that is good. Ln 3 over ln 3 minus ln 5, that's a rule of log. Which rule am I talking about? I'm talking about this thing. Log x base a minus log y base a, that is log x over y base a. That is the rule that is applicable over here. And I think it's all good. Now let's open up the sign. So this is half ln 3 over 5. And this minus makes it positive. That is half ln 3. This is minus 3 over 10. And this is positive half. Half common. This is ln 3/5 minus plus ln 3. And this is 3 over 10 plus 1 over 2. Negative 3 over 10 plus 1 over 2. Negative 3 over 10. And let me write this thing as 5 over 10. So this is 2 over 10, and they have written the answer as 1/5. That is good, and this is 1/5. So this is positive 1/5. Now, how much have they simplified? Let's see, they have kept half as it is. And now another rule of log. Let me write it over there. If this is log x base a plus log y base a, that is log x y base a. This is for multiplication. So since there is a plus sign, I'll multiply these two. So this is ln 3/5 into 3, and this is 1/5. This is half ln 9 over 5 plus 1/5, and I'm lucky, I'm happy that I got the answer correctly. So I think I'll just pause the recording over here. So that is like differentiation and integration. So some questions related with that, and for some other important questions which I feel is necessary, what I'll do is that I'll be making a video and posting it. So that's all from my side on Mathematics with Shahab Yaqub. Take care, everyone. Enjoy and study hard for your exams. Take care.